Chapter 5 of Young and Freedman's University Physics ends with a little bit of an aside in which it basically enumerates the current theory with regard to all the forces that exist in nature, the four fundamental forces, as it were. Since they've been talking about force now for 2 chapters, they seem like this was as good a place as any to drop it in. This is visions of things to come, of course, later on if you follow the physics textbook to infinity. So the four fundamental forces as they are now currently conceived, it's 2016. Gravitational interactions are one force, relatively weak. It takes something very, very, very massive like a sun or a planet for the gravitational interactions to be very significant. Electromagnetic interactions, of course, it wasn't at first that they knew that electricity and magnetism were related, but as it turns out, magnetic forces are simply electrical forces in motion. So those have been combined, for well over a century. But this is a second kind. Electromagnetic interactions are much stronger than gravitational interactions, especially on a small scale. A third kind of interaction is the strong nuclear force. If electromagnetic forces are strong, then you would expect protons and protons being next to each other in a nucleus. Protons we say are positive, and so 2 protons next to each other in a nucleus in an atom, you would expect electromagnetically for them to fly apart, since like charges repel. Somehow or another they stay together, and we call the force that holds them together the strong nuclear interaction. And of course, this is what makes a nuclear bomb so powerful, or makes the sun so powerful. The release of that strong interactive energy. There is another one called the weak interaction. It's only powerful on a very, 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 very small scale, on the size of a nucleus type scale. But when a supernova finally goes supernova, most of the energy from that supernova is coming from the weak interaction multiplied beyond belief. So those are the 4 basic forces as physics currently conceptualize them. There is, of course, been talk of formulating some kind of a theory of everything that could map these 4 forces together to where we had one basic sense of how it all works. We're not there yet, although in the 1960s the electromagnetic force and the weak force were related to each other into what we might call an electro-weak force or an electro-weak interaction, although in physics classes it's still worthwhile to treat them as distinct. We're looking, one day, hopefully, for a grand unified theory that can include the strong. There have been some movements in that direction. I'm not up to date. I know that within about a month of doing this video, they finally have conceded that they've found gravitational waves. I'm sure that is a major step toward a theory of everything. But we don't have it yet. And so there's still work for physics. This seems to be, it feels like we're on the verge of a very exciting time in physics here in the year 2016. It feels like we're going to have some major improvements to our understanding. I don't know that they'll be as big, probably not as big as when Einstein or the quantum, when that generation found things, but it feels like we're about to have something very, very significant.